Hello everyone, my name is Gerson and this is my project for physics. My theme was radio waves. Radio waves are electromagnetic radiation and are one that has greater distance in the EM spectrum. I will describe the history of the radio waves and how this wave is a key factor and sometimes essential in each one's common life, such as broadcast radio and television. Radio waves are generated by charged particles undergoing acceleration, such as time-varying electric currents. Naturally occurring radio waves are emitted by lightning and astronomical objects, and are part of the blackbody radiation emitted by all warm objects. What is the relation with the chapter? Radio waves, as I mentioned before, is a type of electromagnetic waves and has the property of a wave with a long amplitude and period but low frequency. Devices such as radio or TV receive radio waves and convert them to mechanical vibrations in the speaker to create sound waves. The first image at the bottom shows a wave with a high frequency but perhaps with less range, and the one at the bottom of the whole is one with a lower frequency but with a long distance. These next two slides are from 6 topics related to radio waves. The first one is radio waves except for magnetic metals, their alloys, and conductive polymers. Good electric conductors interact with radio waves and microwaves by synchronous generation of superficial, high-frequency alternating currents and electromagnetic radiation with minimum energy losses. The second was electromagnetic energy radiates outwards from the source, usually an antenna, at approximately the speed of light, and it is attenuated and influenced by the medium through which it travels. The third is, basically like radio waves, like other types of electromagnetic radiations, it can produce heat, and may be heated at different rates with impressive selectivity. The fourth is how atmospheric and natural phenomena such as rain, snow, and fog affect the transition of radio waves. Reflections from the Earth's surface, the ionosphere, natural or made objects, and atmospheric refraction can create multiple paths between the transmitting and receiving antennas. The fifth one is radio wave propagation in the frequency range above 30 MHz occurs essentially by direct antenna-to-antenna space waves. This is usually called line-of-sight communications. Further, the higher the frequency of the radio wave, the less it is affected by the ionosphere. UHF and microwave signals penetrate the ionosphere, making satellite and long-distance spacecraft communication possible. And the last is radio waves do not travel at a constant speed. Their transmission velocity depends on the type of material through which the electromagnetic pulses are traveling. In particular, they depend on the electrical and magnetic properties of this environment. The slide below talks about the history of radio waves. Radio waves were first identified and studied by German physicist Heinrich Hertz in 1886. Hertz proved the existence of radio waves in the late 1880s. He used a spark gap attached to an induction coil and a separate spark gap on a receiving antenna. The first practical radio transmitters and receivers were developed around 1895-1896 by Italian Guglielmo Marconi, and radio began to be used commercially around 1900 and used later to broadcast on TV. The next thing I am going to do is present a video with a good way to better understand radio waves.
Guglielmo Marconi's first radio transmissions in 1894 have spread into space for over 100 years at the speed of light. They passed Sirius in 1903, Vega in 1919, and Regulus in 1971. That signal has already passed over 1,000 stars. Anyone orbiting one of those stars with a really good receiver could detect Marconi's signal and know that we are here. Radio waves are the longest and contain the least energy of any electromagnetic wave. While visible light is measured in minute fractions of an inch, radio waves vary from about 19 centimeters, about the length of a water bottle, to waves the length of cars, ships, mountains, all the way up to monstrous waves longer than the diameter of our planet. Heinrich Hertz discovered radio waves in 1888. The first commercial radio station went on the air in Pittsburgh, Pennsylvania on November 2, 1920. Then, in 1932, a major discovery by Carl Jansky at Bell Labs revealed the stars and other objects in space radiated radio waves. Radio astronomy was born. However, scientists need giant antennas to detect weak, long-wavelength radio waves from space. The enormous Arecibo radio dish antenna measures 305 meters in diameter, over 3 football fields. Scientists can link the signals from an array of separate radio antennas to focus on tiny slices of distant space. Such arrays act as a single immense collector. This giant New Mexico array uses 27 parabolic dish antennas shaped into a giant Y, with each arm capable of stretching for 13 miles. Scientists have even spread these linked antennas across the globe. One of the largest stretches from Hawaii to the Virgin Islands and acts like such a powerful telephoto lens that a baseball sitting on the moon would fill its entire field of view. Many of the greatest astronomical discoveries have been made using radio waves. Pulsars, the existence of giant clouds of superheated plasma, which are among the largest objects in the universe, and even quasars, such as this one over 10 billion light-years away, were all discovered using radio waves. Radio waves also provide more local information. Astronomical objects that have a magnetic field usually produce radio waves, such as our sun. Thus, NASA's STEREO satellite is able to monitor bursts of radio waves from the sun's corona. Wave sensors on the WIND spacecraft record the radio waves emitted by a planet's ionosphere, such as the bursts from Jupiter, whose wavelength measures about 15 meters. Radio waves fill the space around us to bring entertainment, communications, and key scientific information. We can't hear these radio waves. When you tune your radio to your favorite station, the radio receives these electromagnetic radio waves and then vibrates a speaker to create the sound waves we hear. We may not be able to tap our toes to the cosmic radio transmissions, but we certainly discovered much about our universe's grand cosmic dance by listening to them.
How does radio waves affect our present? Radio waves allow for long-range communication via mobile phones, television and radio. In the present, without radio waves we could not communicate, and the humans will not increase their development the faster how it was. And today we wouldn't create phones or even see Wi-Fi, because satellites need radio waves to work and science needed to explore the space. We go over the history of radio wave and how people used it for a common in human development. We can conclude that radio waves is very useful and was one of the greatest discoveries in the modern world.